Okay, so I hope you're prepared now. You will have the software installed. So our next or my next video is that I want to show you um, the first steps in the software. So this is just to give you an idea how this software works, so you don't have to do it with your computer or with your software version. Just watch it and try to understand how this software works. So the first step is, I don't know if this is your start screen in Inventor. It might be a little bit different if you start Inventor the first time. But anyway, here, these buttons should be available. So the first button here means that we want to create something new. One remark, you already see that. Unfortunately, it is in German. I can't select this when I install it because I think it all automatically recognizes that I'm in Germany. So I just get the German version without any changes, what I have to do. So it might be in English in your version, but then it doesn't matter because the buttons and the signs are similar, and then you know, okay, um, what you see here in German, then you can find also the button with the English translation, and I also try to translate what this button means. Yeah, and the good thing is you learn automatically some more German words. So the first button here means that we want to create something new, and this is this button I use first. A new window pops up, and this is good because then I can explain what we can do with this Inventor professional software. We can select different icons or buttons. The first here means that we want to create a part. And when I select one of these two buttons, you see in this small window on the right bottom side, it changed because you see here a short preview. Yeah, so this preview here, I think everything is clear because it is a metal sheet. Yeah, so the first button when we want to create a part is that this will be a piece of metal, a sheet, which can be bent in the second steps. Yeah, so but this is not where we start. We will later also use this kind of or this feature in Inventor. We start with a simple three-dimensional part. Yeah, so in my case, standard part. Um, it's automatically in Sol. That's not good. We can select here metrical, and then when we open that, here we have standard again in DIN, or we can choose here in millimeter. It doesn't matter. Same gives us the right unit here in millimeter. So when you open that and go to metric, then you can choose DIN or millimeter. That's up to you. I change it back to templates here because it's a better overview. So this is for parts. The next group here, the group of buttons is, oh sorry, I forgot. EPT here means Inventor part. Yeah, so the file extension, the file, on the file EPT indicates Inventor part, so we create a part here, a three-dimensional part or a piece or a flat metal sheet part when we use the first button. So the second group of buttons has EAM as a file name, and this means Inventor assembly. And when we click on it, we see here, so that is a group of parts. Yeah, so the parts are assembled, or we can assemble the parts when we use one of these buttons. Here we can weld parts together, yeah, and here we can just assemble the parts. So to use the assembly options here, we need to create parts before. So we can only assemble parts when they are already exist. Yeah, so that's important. Therefore, we always start with creating a part. And when we have more than one, two, or however, then we can use here and open a new file, and then we import our parts, and then we can assemble the parts. Yeah, so that's important. We cannot start with the assembly option here. Yeah, we need the first step is always to create a three-dimensional object. That's always the first step, and then we can assemble that. And in the next step, we can create a drawing. Different types of drawing. This is DVG file, which is a little bit related, I think, to AutoCAD. The standard normally is Inventor Drawing, what we see on the extension of the file here, Inventor Drawing. This is what we typically use, and then we can convert it or export to other file formats. But here's the same. We need a part before. Yeah, so we cannot draw in this file. We just can also import a three-dimensional geometry, and then we use this three-dimensional geometry to create what we see here in the drawings. Yeah, so it's not a sketch. We cannot create lines or whatever. Yeah, so the base of a drawing is again a three-dimensional part from here, or an assembled part what we create here. Both can be imported in our drawing file. Yeah, so in the end, something three-dimensional should exist before we use this drawing file. Yeah. And last but not least, we have this Inventor presentation. Yeah, the EPN stands for Inventor presentation. And this can be used to make an exploring visualization, yeah, so how the parts are assembled. So we get a small animation, a small video as an output, how the parts are assembled. This is pretty good to understand when we have a huge assembling group, how this assembling is done step by step. Yeah, so we can create videos here. And again, when we use this file, the presentation file, there should be at least one part already existing, or assembly group should be already created, and this can then be imported and used in the presentation file over here. We start with a EPT, Inventor part. Again, we switch to metric, and to be honest, I prefer the Dean part here. So this includes all what we need. So select this button, and then here click on create. You don't need to do it now. As I said in the beginning, I just want to show you how Inventor works in this short video. So then we are in the Inventor part. Inventor part module. We see we have a lot of different buttons over here, And the first thing what you should keep the whole time in your mind is, if you open a new file, whatever, it always starts on the left side. So the left button here in the corner, this is where we start always. Yeah, if you open a new file, this button on the left side helps you to start. In this case, before we can create a three-dimensional object, we need a two-dimensional sketch. That's always the base, normally. We have here our the steps what we done. So this is our history, actually, our history tree. I will later tell you why this is important, because if we realize that we made a mistake, we do not use this button here to go back. Yeah, so we don't need it actually, because every mistake can be corrected here in our history tree. Yeah, so we go directly to the steps. So all the steps what we do are listed here, and then we go into the step and we change or modify it. Yeah, we don't use this go back button over here, and therefore we have this history tree on the left side. Here we have our working bench, our working area, where we see what we create, where we see the sketch, and so on. Pretty good is that we always see our coordinates in X, Y, and so on direction, so that we know where we are. We also know it because we have here our view cube, of course, with the home button, and we can switch the cube to see our parts from different perspectives. And here also some more buttons to the hand, I think you know, to move it left, right, up and downwards. We can click on the orbital. That means we can turn our part by using our mouse. Okay, you will later see how this can be used. As I said, the first step is we click on the button sketch. And then different planes appears. Now it's up to you which plane you're going to use. I prefer the X epsilon plane, especially for 3D printing. It makes sense, yeah. So because this is our base also for 3D printing, and therefore with the left mouse I can click on that. And again, then I see this coordinate system. This is our center point. It's a good base. And we see in X and epsilon, the coordinates. What I want to show you in this video is also that there are different approaches or different ways to get a geometry. So we assume now that I want to, or the task is to create a cylinder. How we can start? I show you two different ways to create the same cylinder. First way is that I click on one of these symbols here. These are symbols to create lines, circles, rectangles, bows, and so on. I click on circle. Yeah, that's pretty good for a cylinder. You see, if I, with my mouse, if I catch the center point, then it automatically turns to green. And that means my mouse catch a special point. If it's yellow, then it's anywhere. You see the coordinates X and epsilon. But when it catches a special point, then my mouse dot turns to green. So now I got it. It's green. So I click on the left mouse and then release the mouse. Yeah, don't hold it down. That's wrong. Yeah, take your left finger away, and move your mouse. And now I have also two options to set the diameter. The first is just clicking now with the left mouse if you find the right diameter, but it's not so easy. You see, if we say if I want, for example, the diameter 20, so it's hard to get really 20. Therefore, my recommendation is just type in, use your keys to type in 20 and confirm that with the enter button. And then automatically the measurement is visible. Yeah, if you click with the left mouse anywhere, then you have to set the measure by hand. Yeah, I show you, for example, when I start here and then I move and I click again, then I just have the circle without the measurement. And then I use the measurement button and now I can type it in. Yeah, so how can I use it? I click on the measurement button, I click on the circle, then move your mouse to find a position for the measurement, click again, and then you can type in also 20. But to be honest, the first way, yeah, directly type in the diameter 20 is the better way. For our cylinder, this is good enough. We have a two-dimensional geometry, so therefore I can close the sketch with this green tick here. I click on this button to close the sketch. And now our 3D buttons are back. I have different buttons here. What we normally use is extrusion. So we want to extrude. I click on it. We want to extrude our circle to create a cylinder. Okay, let's assume our cylinder is also, let's say 30. To extrude something, we need always a closed profile. Our sketch should be closed. Yeah, if we, for example, use just lines or both, and they are not closed, then there's nothing to select. Yeah, so the sketch should be closed like our circle. If there's only one closed profile or sketch, then Inventor automatically select this. Yeah. Otherwise, if there are more closed profiles, then you need your mouse to click on the profile to select it, and then it will show you this preview as we see it here. Then you need to define the distance, in my case 30, and then I click OK. So that's what I want, a cylinder, and I want to show you now another way to come to the same result. We start here again. The first step again is a sketch. I choose the plane, but now I use a rectangle. I click on the rectangle, and in this case I start here in the center point again, and you see the blue measurement over there, and I type in here now for the blue thing 10. And now I can't move it, but I want to change also this measurement over here, and this can be done by the tab button. Yeah, use the tab button, and then this dimension is blue, and here again I type in 30, and then I confirm it with enter. By using our scroll wheel in the middle of our mouse, you can zoom it in and zoom out, and by holding down the mouse wheel and moving the mouse, then you can start this hand feature here. Yeah, so scroll with your mouse wheel to zoom in and out. If you push down the wheel, you can change the position. Okay, that's it. You see here some signs, which means they are all parallel. Yeah, so there are for Inventor also some more information stored, in this case that they are all parallel. I close the sketch, and now I use the second button over here, or in total the third, for turning. I click on that, and again we have only one closed profile which is automatically selected. Yeah, I don't need to select the profile. If there are more than one, then I have to click on the profile what I want to use with this feature. And it automatically jumps to selecting the axis. And this is our turning axis. So for example, if I select this line as a turning axis, you see directly the preview, and here you see in which direction it turns, and we can define here also an angle, let's say 180 degrees, then it's just a half of a cylinder, and so on. Yeah, in our case, the 360 is good enough. If I confirm that with OK, I got my cylinder. It's the same. Yeah, maybe the orientation is different, but the result actually is the same. It's a cylinder. And yeah, these are the base how I can use Inventor. I already mentioned that we have in our history tree here all the information and all the steps. And for example, if I'm not happy with the dimensions, yeah, so I see maybe later, oh, there's a mistake. The length of the cylinder should not be 30, it should be 40. Then I open it here, yeah, where we turned it, and I see the sketch is there, and double click with the left mouse. I jump directly into the sketch and double click on the dimension, and then I can type in 40, for example, change it, and when I close it, my cylinder changed. So I don't need to go back all the steps. I just jumped into the step where the mistake is located. Yeah. So that's it. That's the first step. The last step always, if you finished your object, is to save it. Yeah, but in this case, I don't need to save it. It's just to show you how Inventor in general works. Yeah, so in the next video, we start with our first part, what we need to create this assembly group over here. We start in the next video with this bolt. Yeah. Okay, so please open the next video.